Welcome back, I'm Chili, and today we are gonna make a menu. So let's get on that. Time's a wasting. So first thing we gotta do, as usual, we go to unsync commits, we gotta synchronize. And that'll pull all the new data off of GitHub for us. Hurry up. It was actually a little slow for me earlier just trying to push this from my development project. There we go. We have synchronized. Now what we want to do is go to branches, new branch, and menu X. The X is for, I have no idea. I wrote this code like a month and a half ago, but here we go. Here we are. So let's take a look at the history. And menu X has one commit, and the commit comment is made a menu fuckers. So there you have it. I'm not saying you have to use the same naming conventions that I do, but I recommend it. Adds a little touch of professionalism. Now, obviously the meat of this commit is going to be in menu.h. But let's take a look at some of the other ancillary stuff here. We'll get that shit out of the way, and then we'll go to the stuff that we want. So first things first. What did we change in rect? Nothing huge. I think I just added an underscore in front of all of the definitions for the class name because that's the way I like to roll. I like to use underscores for the template class name, and then I can use non-underscores for the type definitions for integer and float. That's just how I roll, so I changed that up. I think I used this. I got this code from Albino Papa when my hard drive exploded, so he didn't have the underlines. What a guy. Erasing my underlines. I don't believe it. Anyways, next thing is apparently in Surface, I wanted to use putPixel instead of using array indexing on the buffer. So I used the putPixel call function instead. Not a big deal, just making it consistent, I guess. What else? We got rectangle, we got surface out of the way. What about title screen is going to be some stuff. So, okay, I put a bunch of functions into d3dgraphics.h, but there's really nothing new here. Some things I just moved around. Like if you look here, copy surface, begin frame, end frame, draw. I think I just moved that shit up here. Yeah, see here we got copy surface, and what else? I don't know. Here's begin frame, end frame. So I just kind of reorganized a bunch of bullshit here. But I also did something substantial. Alright, if you look at... This is actually kind of distracting. So we're going to go to D3D graphics in the framework. 3dgraphics.h. Here we go. Alright, so if you look at draw rectangle, we've got a templated version, a couple of templated versions, and we've got the main version right here. No, that's draw circle. Never mind that. Where's draw rectangle? Where does it start? It starts here. It starts here. Here we go. Okay, here's the main version of draw rectangle. This is the version that actually has the implementation in the CPP file. And this version, it takes the normal parameters. You got left, right, top, bottom. You got a color. And then you've got this weird bullshit right here. What is this bullshit? This is a pointer to a function, but it's a special one because it's a pointer to a member function. Why is my freaking screen keeps scrolling over? Anyways, so a normal pointer to a function would just be void, parentheses, then your parameters, then close parentheses, and that's it, right? I think that's the way you do it. There might be an asterisk in there somewhere. I don't think so. Anyways, that's a normal function pointer. If you want to make your function pointer to a member, fuck you. What you got to do is you put the class's name, and then you put the scope resolution operator, and then you put the asterisk in there. And you put brackets around this shit like this, and there you have, you're declaring a pointer to a function. And that, yeah, I don't have the name of it in here. You don't need the name in the whatchamacallit, declaration, obviously. And here it has a default parameter, and that default parameter is put pixel. So when you're giving a pointer to a member function, you've got to put the ampersand in front of the name. You don't have to do that with normal functions. You just put the name of the function. But if it's a member function, you got to put the scope resolution operator thing here and the ampersand. So what we're doing here is we're parameterizing our draw rectangle such that we can specify, I meant go to definition. There we go. What the fuck? I said go to definition. Where? Busting my balls here. Where is draw rectangle? Draw. Circle, flat triangle. Was at the top. I missed it. Draw rectangle. Here it is. Okay. So here we have the pointer to the member function. You see here, you put the name of the pointer right after the asterisk here. So you put it in the middle, which is weird. Normally you have type and then you have name. Here the type is actually in the middle. But that's the way you do it. And here is how you call a member function. So you have a pointer to that class, and then you call it with this pointer access, then dereference, then the name of the pointer, and you put brackets around that, you put brackets around your parameters, and you're all good to go. Now what this lets us do is this lets us to create from one definition, lets us to create multiple versions of draw rectangle. We can have normal draw rectangle, which defaults to just put pixel, or we can have draw rectangle alpha, and that one overrides with put pixel alpha. And we can have the same function be called with different put pixel functions, and that will give us different behaviors on how it rasterizes our primitive. Now this is not, it's not a big deal for draw rectangle because it's a small function. We could just as easily put, copy and paste and put this one put pixel and put the copy with calling put pixel alpha. But imagine now you want to draw an alpha, or you want to draw a triangle, a textured triangle with alpha. Well, now you've got all this bullshit. Do you want to copy this function for every version, for the alpha version, for the non-alpha version, for the key-coded version? No. What you want to do is you want to have one version, and you parameterize it also with what rasterizing function you want to use. So that's what I want to do eventually, is I want to be able to have an alpha version of draw triangle and a non-alpha version, and not have to copy and paste the function right. Two versions of the same function that are almost identical, except that they call different functions at the end. One calls put pixel, one calls put pixel alpha. Instead, we're going to parameterize that shit, but we're going to do it later. Right now, we just tried it out with draw rectangle, which will be useful because we're going to be drawing alpha blended rectangles for our menu. So that's one thing I wanted to talk about. The other thing is, of course, the actual menu itself. Now, the way the menu system is going to work, so far, I haven't decided. I might change it, but I think the way we're going to do it is we're going to define a menu class, and we're going to define a menu item class. And a menu is going to contain a bunch of menu items. It's going to be a container for items. So here this is the menu, the members of menu, and it's going to have a vector or the important thing is to have the vector of items. All the rest of this stuff is just basically graphical stuff, like the extents of the borders, the colors, padding, fonts, more colors. We've got a vector, and that is all of the items in the menu. They could be buttons or they could be other things. And here we've got an iterator, and that just tells us where we are in the menu. All right, so the menu is going to be, it's not going to be mouse based. I decided that. Not that it would be that hard to make it mouse based, but this game is going to be mostly focused on keyboard and controller. So I decided against mouse for the menu for now. So how does it work? Well, I guess the guts of the class is in this handle input function. It takes a key event and it, does some behavior based on what key event was in there. If it was up, it's going to increment the where is it? It's going to increment the iterator that's pointing to the current member item. So it's kind of complicated, right? If it's up, you want to decrement the pointer. You want to go up one. But if we're already at the beginning of the list, we want to go to the end. So I'm allowing the selection of the menu items to scroll. So if you press up when you're already on the very top, you go to the bottom. So if we're equal to begin, we set it equal to end -1, which is the last item in the container of items. And we also, every item in the menu has its own Boolean variable to tell whether it's selected or not. Because obviously selected items, you want them to display differently to indicate to the user which one is selected. So how you do that, or how I'm chosen to do that, is by maintaining a Boolean value in each of the menu items, keeping track of whether it's selected. So when you press up or down, first thing that happens is you deselect the current item, then you change the iterator to point to the new item, and then you select that item. The same thing but in reverse for down, and if you press escape, you quit. So those are the three basic key presses that the menu handles. Any other key presses it gets, it forwards them on to the menu item. So this iterator points to the menu item, and we call handle input with the key for that. So that's implemented in the individual menu items. But up, down, and escape are trapped by the menu itself. What else? You got draw. All that does is it draws a alpha blended rectangle for the border of the menu, and then it draws each of the menu items. That's it. What else we got here? We've got an add item function here that lets you add a item to the menu, and finalize has to be called after you've added all the items to the menu. So this is called in the constructor. Add item is called in constructor, and then you call finalize at the end, and it sets the iterator to the first item, and it sets the first item to be selected true, and it sets a flag stating that the menu is now finalized. So you can't finalize it twice. And you can't work on a menu if it's not finalized yet. That's why we have this assert here, assert finalized. So if you forget to finalize and you build it in the debug mode, you will get an error telling you that you fucked up. All right. There's some other stuff here that I'm not going to go into too much depth here, but basically there's some calculations here to calculate the borders of items based on certain parameters that you set, like the padding and the overall general dimensions of the menu. And once you set those parameters, it'll automatically calculate the borders of the items, so their dimensions, and the borders of, I think this one calculates the borders of the menu. I don't know the exact Yeah, so this one calculates the borders of the menu based on a center point where you want the menu at. And then the width and height you want of buttons, padding, all that good crazy horse shit. And that stuff is called in maybe here. Yeah, calculate borders is called here. And calculate item borders is probably called in the items. So, item, yeah, here we calculate item borders. And that calculates the border of every item. Okay, so in item, what do we have here? It's a friend of menu, so menu can access its bullshit. And it has some virtual functions that we override when we inherit from item. There's one for update, there's one for draw, and there's one for handle input. It's got a, lets you check to see if it's selected or not. And it's got some stuff here, like it's got the boolean here to keep track of whether it's selected or not. It's got a little bit of a cache here to reference to the font that it uses, and it remembers its own borders, and that's it. Now, item is meant to be a bunch of things. It can be a button. It could also be a like a selection where if you press left and right, it changes the options. So like a multi-selection with options. It can also be like a drop-down menu where you press the enter button or whatever button is equivalent to that, and it opens up a sub-menu that you can scroll up and down and select options from. So it could be a bunch of different things. But right now I've only implemented a button. So there's a subclass from item called button, and what it does is it inherits from update, and it doesn't do anything. So there's nothing that has to be updated every frame. You might want to use this if you want like a button that has animations, like a glowing button, to show like if the button is selected, maybe the color of it glows, fades in and out. And you could do that by using this update. But we don't use it. And draw, all draw does is it draws a rectangle. If it's selected, it draws one color. If it's not selected, it draws another color. And then it draws the string, which is the button's text, inside of the rectangle. And for handle input, if button is pressed, it calls on press. And on press is this is a pure virtual function that's introduced here. And this has to be implemented by the class that actually uses the button. So this is still just a virtual class. Can't be instantiated. And that is really about it. So what you do, if you want to make a menu, is you inherit. Where's menu? I guess it's all the way up here. You inherit from menu. You create my menu, public menu, and then you inherit some buttons from button, and you implement their behavior by overriding on press. And then in the constructor for your menu, you're going to call add item for every menu item that you want. Then you're going to call finalize, and that's it. Then you're done. Well, you also probably want to implement on exit to know what happens when you exit the menu. So what does that look like? Well, we're going to go to title screen, and we're going to see. So what I've decided to do is I've decided to implement the menu inside of the title screen. I could have created a separate screen for the menu and then layered that over top of the title screen. But I decided to put it all in one thing. So what we do is we have a unique pointer to our menu. It's called start menu because that's what we call our thing that inherited from menu. Class start menu, public menu. And what we do, let's just get rid of this. What we do here is first we got to check to see if the menu is active. So when you start up, the menu isn't active. You just have the splash screen that I showed you before. And what happens is in handle input, if menu is a null pointer, if it doesn't have anything, then we check to see if we've pressed return, and if we have, we create a new menu. So the menu pointer holds the menu, but it also serves as a boolean to tell whether the menu is active or not. So if we don't have a menu, then we check to see if we're going to press enter, and if we did press enter, we create the menu. If we do have a menu, then we pass our input onto the menu. And similarly in draw, if we have a menu, we draw the menu. Otherwise, we draw a string saying press enter. That's just prompting the user to do what they need to do to open the menu. So all the work, or most of the work, is done in, where is it? Is done in the menu. We inherit from menu, creating our own specific menu, start menu. And we inherit from button to create two buttons. One is the exit button, and this one just has it overrides on press and it tells it to exit. So these buttons, they maintain references to the parent menu. And this one calls menu exit if you press the exit button, obviously. This one calls a function on screen.newGame if you press it. So start button, this one maintains a reference to the screen. This one maintains a reference to the menu. So the beauty of being able to inherit from button and then create your own buttons that way is you can configure it. You can add all sorts of behaviors, anything you want. It's up to you. You're the master of your own destiny. Whereas if you had to create the buttons by just passing parameters, you would have less freedom. So, start menu. What do we have in the constructor? Well, we have to add first we do the normal thing, right? We have to instantiate the parent class, which is menu, which is, where does it go? That's here. So this line and this line are just instantiating the parent class of menu. So we input things like, I don't even know what all this stuff is, but I'm guessing this one is the center of the menu. And here are some parameters for padding and whatnot. And here are some maybe some parameters for button dimensions. I can't remember what they all are, but they're all good shit. I mean, we could go to menu. We could look. What are the parameters for menu? You got the center of the menu. You've got button width. You've got padding, button height, color of the background. Here's a string. I don't know why, but here's a string. Oh, that's the name of the font. That's the name of the font for the menu. Text color. I don't know where. It's kind of weird, actually. I'm not exactly sure. Wait, where's my title screen? There it is. I'm not exactly sure where the 4 parameter thing is coming in. This one. What the fuck is this? That's the first, second, third, fourth, fifth parameter. So that's what? Let's go down here. First, second, third, fourth, fifth. Oh, that's the color. Okay, that makes sense. Yeah, color. It's got 3, RGB alpha. So that's fine. All right, that makes sense. Just checking. All right, let's go back to title screen. Let's see here. All right. So we pass all the important information onto the parent class. And we also initialize this reference to the title screen in here. So the menu keeps a reference to the title screen that encloses it, so that it can perform certain actions when necessary. Like when we exit the menu, the action that we perform is we release the pointer to the menu in the parent. That destroys the menu. And that also signals that the menu is now inactive, so we don't try to draw it and shit. So in the body of the constructor of our menu, we just add the 2 menu items by calling add item. And then we finalize. And that's it. After that, everything is handled in here. It's all automatic. We had to add a new function here called new game. And that's just so that the menu can call new game, or not the menu, but the new game button, start button. It gets a reference to the start menu, and it uses the parent, menu.parent. It keeps track of that, and it uses that to call new game when we press the button. That's it. That's all there is to it. It's a lot of, there's a lot of stuff in menu, but the beauty of this system is that once we set this up, it means that we have to do a lot less code. We don't have to, when we create the menu in, for example, in title screen, we don't have to worry about all the code for handling button presses, press up, press down, what happens. All we've got to do is just implement the behaviors for the buttons that we want to make and for the menu itself. So all the boilerplate stuff is handled in the base classes. Now, the one thing I don't like about this is it's hardwired to certain keys and in key event. It's hardwired to be a key event. But later on, we're going to want to use the gamepad, so we're going to have to change the way that it handles input. But for now, it's fine. So let's take a look at what it looks like when we build it. And here you go. You've got your HUGS. And here, press enter. So we press enter, and here comes our menu. So we've got the border of the menu, and it's being drawn with alpha. And then we've got the two buttons. And we can press up and down, or just press down, or whatever. Cycle between that. If we press exit, we go back to this. If we press escape, we go back to this. If we press enter on new game, we enter our countdown screen, and when the countdown finishes, the game screen becomes the master screen, and it begins processing. Whoa! There you go. And I'm dead. Well, now I'm dead. You can press enter to restart, and it goes back here. We could also have set it up to go back to the title screen when you die, but it doesn't matter. We'll worry about that bullshit later. The important thing is that now we can have menus, which we'll be using later to configure options, like to be able to configure the inputs on the controller, and also to be able to configure the screen dimensions and stuff like that. But that is a story for another day. For now, I think we've done enough for today. So we're going to wrap this one up, and next time we come back, we are going to delve into the world of direct input. And let me just tell you, it's fucked up. But hopefully we can make some sense of it. Until then, it's Chili signing off. Have a good day.